We're now going to introduce another concept called the order of convergence. So let's imagine that we have a sequence of n elements. Let's call it xn, with n going from 0 to infinity. And going from 0 to infinity, and let's suppose that this sequence actually converges to some value L, with xn not being equal to L for all n. Now we can introduce two positive constants, let's call them alpha and mu, and then formulate the following relation. So we can say that the limit with n going to infinity of the absolute value of x n plus 1 minus L divided by x n minus L to the power of alpha is equal to mu. So what we're saying essentially is that the sequence converges to L, and the order of convergence is this alpha. So alpha is the order of convergence, and mu is some asymptotic constant. Asymptotic constant. All right, so we have, let's say we have some iterative technique for finding the value of x. So we have x n equals some function g of x n minus 1. And we can say that this iterative technique is of order alpha if the sequence actually converges to the solution of order alpha as outlined above. Now, in general, a sequence with a high order of convergence will actually converge more rapidly than a sequence of a lower order. And the asymptotic constant that's here on the right basically affects the speed of convergence, but not to the extent that the order does. Now, two cases of the order of convergence should be given special attention. So first of all, if we have a situation where alpha is equal to 1 and mu is less than 1, then the sequence is linearly convergent. Linearly convergent. And the second case that we need to mention is alpha being equal to 2. In this case, the sequence is quadratically convergent. Quadratically convergent. So essentially, if you think about a fixed point iteration algorithm, this has linear convergence. And on the other hand, something like Newton's algorithm, for example, has quadratic convergence. So let's take a look at an example of what the calculations would be for linear convergence and quadratic convergence. Just some sample numbers to get a feel for what you're getting, essentially. So as you can see from the illustration, the quadratically convergent sequence is within 10 to the minus 89 of 0 by 7 terms, whereas to achieve this kind of accuracy with linear convergence, you would have to have at least 126 terms to achieve a similar result.